For thousands of years, the brightest minds have struggled to unlock the secrets of vision, which we now know involves converting the light from images we see into electrical signals that flow through our brain. But how do these signals get to our brain? And how does the brain control the eyes? Let's take a look inside with Dr. Roten. We start with the eye, which is our window to the world. Vision begins in the globe, inside the eye socket, which is also called the orbit. Nerves from the brain activate muscles that turn the eye in, out, up, and down, and some also rotate the eye. Light passes through the clear window of the eye called the cornea, and then through the lens behind it, which focuses images at the back of our eye. If the eye is like a camera, then the retina is like the light sensor. Here, light from images is converted into electrical impulses by specialized cells. The output of these cells converge to form the optic nerve, a cable which carries these signals to the brain. Here we are looking behind the eye, which has been removed so that we can better see the optic nerve between the muscles of the eye. Now we are looking at the bones of the orbit. This small hole is where the optic nerve exits the back of the orbit to go deeper into the skull where the brain is. This slot in the orbit is where the nerves that control the eye muscles enter the eye from the brain. Let's open up the side of the eye at this slot to see these nerves. Now we are looking at the left orbit from the side, and we can see the optic nerve, which is transmitting electrical impulses representing vision out of the orbit and into the brain. Other nerves act as control wires, activating the muscles that move the eye. Now we are going to look inside the skull from above, particularly the front where the eyes and optic nerves are. The roof of the orbit is here, and we can see the optic nerves leaving the back of the orbits to pass deeper into the skull where the brain is. The roof of the orbit has been removed to show the eye from above. Several of the muscles that move the eye are seen. This nerve carries signals from the brain that causes the eye to move. The optic nerve is covered by a thin protective sheath as it travels out of the eye towards the inside of the skull. Looking beneath the brain from the front, we see the optic nerves joining together to form the optic chiasm. Here, some of the fibers cross to the opposite side of the brain. The net result is that the left half of the brain sees the right side of the image, and the right side of the brain sees the left side of the image. This is a view of the brain from below. We see the optic nerves entering the optic chiasm. The visual pathway then makes connections at the brainstem, which are hidden in this picture. The electrical signals then continue through the temporal lobe and into the occipital lobe. In this picture, the temporal lobe has been partially removed on one side. We again see the optic nerves leading to the optic chiasm and then to the optic tracts, which then connect to the brainstem. Here is another view of these connections using a picture of the brain sliced so that we can see from the front. The optic tract is seen curving around the brainstem, to which it connects at the lateral geniculate body. Visual fibers then leave this area of the brainstem and travel inside the temporal lobe as the optic radiations. Now let's look at things from the side. Portions of the visual fibers travel inside the temporal lobe and the parietal lobes of the brain before finally arriving in the occipital lobe, which is the visual center of the brain. Here the layers of the brain have been peeled away so that we can see the lateral geniculate body and the visual fibers that are heading to the occipital lobe. Now we are looking at the inside surface of the brain. Between the upper and lower halves of the occipital lobe is a cleft called the calcarine sulcus. The brain surrounding this cleft is the primary visual cortex. Here the brain starts to analyze primitive features of the image, such as edges and their orientation. Cortex in nearby areas then does more sophisticated analysis, such as recognition of movement or objects. Our journey is now complete. Thank you for exploring the visual system with Dr. Roten.